We've just developed a new technique called fluorescence enhanced photothermal infrared, or FL-PTIR. And this is a new high-speed, wide-field technique for doing infrared chemical analysis, chemical imaging, and spectroscopic analysis. And it's based on detecting changes in fluorescent emission from a sample based on temperature increases from infrared absorption in a sample. What we realized was that fluorescent molecules, for example, fluorescent dyes used in fluorescence microscopy or intrinsic fluorophores that lead to autofluorescence, they have a very, very high temperature sensitivity of about 100 times bigger, about 1% per degree C. And so when we hit these same samples with infrared light, pulses of infrared light, and they absorb that light for a 1 degree temperature rise in the sample due to that infrared absorption, we get 100 times bigger signal. And we can now use traditional fluorescence cameras to capture that infrared absorption, not at a single point like we were doing with traditional OPTIR, but now we can measure thousands or hundreds of thousands of points simultaneously. And so it's led to the ability to perform infrared spectroscopy and chemical imaging at much, much higher speeds than previous techniques. So for example, we have been doing measurements recently where with this wide field FL-PTIR technique, we can acquire 250,000 infrared spectra over the fingerprint region with, say, 4 inverse centimeter spectral resolution. We can acquire those hyperspectral arrays in 10 or 20 minutes, whereas a single point measurement using traditional OPTIR takes about a second per spectrum, so it would take about 72 hours, 3 days to acquire that same data that we can get now in 10 or 20 minutes. We are super excited about the application areas for OPTIR and how they're going to be extended by FL-PTIR. For example, some of the really exciting research that's going on right now is in areas of critical biomedical need, for example, research into Alzheimer's disease and cancer diagnostics and treatment, things like that. We can image much larger sets of data more quickly, so we can provide more information for the researchers to understand the mechanisms of disease and avenues, pathways to potentially address those diseases. And then the other thing is the previous OPTIR technique had the ability, or has the ability, to obtain chemical images, but the typical chemical images take a few minutes per image to acquire. And we can now get images in fractions of a second, as short as, say, 200 milliseconds. And so that opens up entirely new applications to study dynamic events. You know, what dynamic events are happening in a live cell, for example.